Hello, and thank you everyone for joining us today. My name is Sean Severson, co-founder and president of Water Tower Research and head of sustainable investing research. Today we have Gregg, Dixon, the CEO of Voltus, with us, and we'll talk a little bit about the business, what it is, and a little background as well as where they're going. It's currently going in the SPAC process, so we'll spend a little bit of time on that in terms of the structure and how we got there. But again, want to focus on the business itself today. We will be able to ask, the audience will be able to ask some questions. In the bottom left-hand corner, you will see a box that says ask a question. If you submit your questions there, we'll be able to read them on our end. If you're viewing this on demand, you can also ask questions as well, and we will receive those and pass those along to the company. So with that, I'm going to go ahead and jump right into it, Gregg. And as I mentioned, I think it's healthy to start with a little bit of background on yourself and the company and the current structure and where you're going with it.
Sure. Well, Sean, first, thank you very much for having us. Really appreciate it. It's always good to see you. So starting with my background, I've been developing the distributed energy resources market and technology for 20 years, cutting my teeth in on-site or micro cogeneration in the early 2000s, and then spent 11 years leading go-to-market functions in demand response at Enernoc, and then as co-founder of Voltus in 2016. To frame our discussion, I always like to kind of define what distributed energy resources are. I'll refer to them as DERs. They are electricity storing, producing, and consuming devices that lie behind electricity meters and can be controlled as a network. And that network is often referred to as a virtual power plant. And these virtual power plants deliver the same services as traditional central power stations while being paid the same for those services by the grids that value those services. And these DERs at scale dwarf the capacity of central power stations as we know them today. An example of which is the fact that there will be 2 million megawatts of lithium-ion batteries in American vehicles by the year 2030. Now, to put that single DER use case, of which there are hundreds of use cases, into perspective, the entire United States peak demand for electricity today is about 800,000 megawatts. Now, these DERs can deliver services along the two market dimensions of the distribution or the utility level and the transmission or the wholesale market level. So I think with that framing in mind, the other questions will be easier to answer.
Great, thanks. Let's spend a little more time and dig into that. DERs are obviously a great untapped asset. And, from your perspective, as you look at the market opportunity, how are the customers, your clients, I should say, approaching this? I mean, is this more missionary work where you're going to them and really doing business development, showing what they can do? And how are they structuring their thinking about, microgrids and DERs that they have?
Yeah, so, we often use the Airbnb analogy. So Voltus is to electricity what Airbnb is to real estate. So, if you have an apartment or home that's underutilized and can generate extra cash, you don't go about creating a technology to connect that home to the market. You use Airbnb's software platform to handle all the complexities of that two-sided market at no cost or risk to you. Voltus's software platform does exactly the same for these DERs, except that the complexities of electricity markets are even more daunting. And at the end of the day, our customers that fall into two segments, the large commercial and industrial energy consumer and these large DER technology partners, they're attracted to the cash that they can generate from DERs that have a primary use case that is not to monetize them in these electricity markets. So ultimately, we deliver more cash to these customers by technologizing, if you will, that resource at no cost or risk to the customer where they just couldn't do it on their own.
Can we take a step back and actually talk about the market itself? I mean, explain, investors that are new to this, talking about utilities and wholesale markets and DERs and just the landscape, the playing field that you operate in.
Sure. So as I mentioned, there's essentially two layers to electricity markets. There's the local or distribution level or utility level. So we all have a local utility we get our electricity bill from. That's the distribution layer. Then there's the transmission layer or the wholesale market. And most folks aren't even aware that there's a wholesale power market. Utilities within a particular region are typically members of these wholesale power markets. It is one of the challenges of these markets in that in the US and Canada, there are 9 of these wholesale markets. There are 3,300 electricity utilities, many of which are part of these markets. There are states that have public utility commissions. There's a Federal Energy Regulatory Commission that oversees these balkanized and quite Byzantine markets. But you can boil it all down to those 2 layers. There's the distribution layer, there's the wholesale market layer. And these grids need to be balanced in real time between supply and demand. How that is done in every one of these markets is slightly different, but the physics is exactly the same. And so within the construct of these markets, we utilize DERs using our technology to aggregate, orchestrate, and monetize them in markets to essentially deliver value to the owners of those DERs.
And you can essentially create a portfolio of DERs to work with the wholesalers, right? So you're pooling these assets together and then going directly to the wholesale markets.
That's right. So wholesale market, traditionally before the advent of DERs would simply be working on the supply side of the equation. So as consumer demand on a hot summer day rises throughout the afternoon with the increase of temperature, traditionally what would happen is more power plants that would be sitting idle are turned on to supply more power to meet that demand. Grid operators really don't care whether they put more supply on the grid or they take demand off the grid. Their job is to simply efficiently balance that supply and demand equation. What DERs offer is a way to reduce demand behind meters to create that balance. And so where a grid operator might turn on, say, a 500 megawatt natural gas fired peaking power plant to meet the needs of rising demand, instead, what we can do is eliminate 500 megawatts of demand by orchestrating thousands of these DERs to take the burden off of the grid. For instance, we might run an on-site generator at a big box retailer. By supplying that power of the retailer with a local resource, it is effectively eliminating its demand from the grid. Or we might inject power back into the grid through electric vehicles or stationary energy storage, as opposed to getting it from that natural gas-fired peaking supply-side resource. We measure all of that power production or reduction in real time. We control it in real time with our technology. And no differently than that 500 megawatt natural gas-fired power plant, our 500 megawatt virtual power plant settles in the market no differently, except that it is then disaggregated across those resources and settled at an asset level for customers.
Let's go back to the technology itself for a minute, not to dive into too much detail, but can help us understand the platform, the technology, how it works as a service, software as a service model, and we'll get in a little more of the economics later, but just the technology itself and the application.
Sure. So our technology platform, which comprises software and hardware, automates every bit of the DER delivery spectrum, from the internet addressable machine, some of which I've mentioned already, whether it's electric vehicle or an on-site generator, to the electricity meter. So we're always collecting this real-time electricity meter data for settlement purposes, to the actual market itself, whether it's a utility or a wholesale power market that needs you to prove the performance of this resource and these assets, right to the money that ends up in the form of digital payments to the consumer. So we've fully automated that entire delivery spectrum. So I'll give you an example. I'll go back to the big box retailer with that on-site generator. Its primary use case is to deliver backup power if the grid goes dark. So let's say you have a Walmart or a Target in Texas that has experienced the effects of Winter Storm Uri. That generator is sitting idle for, all but a few hours a year, if that. maybe it's run a few times every 5 years, to make sure that power is provided to the store if the grid goes dark and they can continue to deliver their services and product to the consumer. It's a sunk cost, and the asset, again, it's used very rarely. Voltus comes in and we layer in our technology to fully automate the control, the dispatch, the performance, the market integration, the settlement, the payments for this resource within an aggregation of DERs known as a virtual power plant. What's truly proprietary about this whole technology platform is that cache is the entire customer experience, which is what they care most about. So our DER platform is a fully automated, auditable, real-time accounting system for any type of DER a customer has in any market that we operate.
So let's look at the cash aspect. I mean, that's what we get down to. How do you make money off of this, and how do your clients make money off of this?
Sure. So, using the Airbnb model, which is very analogous to what we do, Airbnb takes about 15% of that transaction between the host and the visitor. Voltus, for delivering an almost identical service, takes about 40% of the transaction with virtually no supply chain risk and negative working capital. So let me give you an example. Let's say we have 100 of these stores of big box retailers, again, in Texas. And let's say each of these stores has a megawatt, 1,000 kilowatts at each store that we can aggregate into a virtual power plant into the market. So we may install some hardware, we may not. We may simply use a software API to automate the control of these on-site generators to deliver their grid services. In this example, we've got 100 stores, each with 1 megawatt. So we're bringing 100 megawatts of capability into, in this case, the ERCOT wholesale power market. Well, let's say that a megawatt is worth $5,000 or $50,000 per year. That 50,000 times the 100 megawatts is $5 million. By nominating or registering these loads into the market, ERCOT pays Voltus. We get paid every week for ERCOT having the option of dispatching this virtual power plant if and when they need it. These virtual power plants may run 20, 40 hours a year. They're actually not called very often. And we hold on to that money every quarter. This is where the negative working capital comes in. And then we pay our customers every quarter. So that's our primary cost of goods sold. And they get about 60% of that transaction. So again, Voltus takes about 40% of the transaction. We are paid by the grid operator or the utility prior to incurring our cost of goods sold. And we are enabling existing resources. We don't install batteries. We don't install solar. We're simply enabling resources lying fallow in the ground today and acting like the Airbnb of electricity markets.
Do the customers have any perceived risk, when they're looking at this? I mean, why wouldn't everyone do this? When you get pushback, what is it? Is there any real risk to the customer? And then also the length of the contracts and also the consistency of the cash generation.
Sure. So there's never any risk to customers. There's never any cost to customers to participate on our platform. In recognition of the fact that these electricity markets are so complex, we have structured our commercial offering so that it's a single page, no cost, no risk agreement. You or I, not being attorneys, can read it, understand it, and within minutes sign it without fear that there's risk or unknown cost in that agreement. Which is why we have such a quick sales cycle. From first contact to ink on an agreement, it's about 73 days. And as you might imagine, at the end of that typically 30-minute meeting with a customer, they say, well, why wouldn't I do this? And the answer is, there is no reason. You should do it if it makes economic sense to you. But when customers don't avail themselves of this opportunity, it tends to be in two categories. The first is economics. In some markets, the economics just don't make sense for a customer to deliver, say, load flexibility. They might not want to shut down because the cost to do so is more than the revenue or value they would generate for doing so. And the second reason is really more associated with the customer adoption curve. So sometimes you'll run into a laggard, if you will. So if you think about the typical customer adoption curve, at the beginning of which you have the innovators, you have the early adopters, you cross the chasm into the early majority, then you have the late majority and the laggards. You may be serving 20 wastewater treatment plants in, say, Southern Illinois, and you run into the 21st wastewater treatment plant and they say, you really need to have 21 wastewater treatment plants under your belt before I'll sign on to. So it really falls into those two categories. It's just economics. It doesn't make sense for them. Or they're just very conservative and they want to wait to see more of themselves participating in these markets.
It's also important to understand this isn't just a startup now. This isn't an experiment or bleeding edge technology. You have a real customer base. You're in the market today. So maybe talk a little bit about that. That this is established, it's out there, and it's proven.
Yeah, it's not only established and proven, but it's desperately needed by grid operators in the face of incredible trends that are dramatically changing these electricity markets. So we see the incredible growth of intermittent renewable power. A recent example of which is in the Mid-Continent Independent System Operator market. On Thursday of last week, we saw the highest ever clearing price in its entire history at more than $86,000 a megawatt year. And that was due to the effects of increasing renewables coming online and fossil fuel power plants retiring. There's a whole dynamic in there, but it's really driven by the fact that intermittent renewable power with, say, a nameplate rating capacity of 1,000 megawatts of wind might only be accredited or can deliver on average, say, 300 megawatts of power, whereas 1,000 megawatts of coal nameplate rated capacity might deliver 950 megawatts. And so what is happening is these intermittent renewables that will continue to penetrate these markets will create price volatility. DERs offer an incredible dance partner and backstop for the intermittency of those resources. The second is that we see electrification of energy, right? We see the automobile moving from fossil fuel to electric, and that will create new demand on grids that really haven't seen electricity demand growth for years. And so grid operators are needing additional resources that can come online quickly and at scale. And DERs are really the only resource that can very quickly enter markets at scale. So an example of which is there's over 40 million Wi-Fi smart thermostats in the US, which amounts to about 40,000 megawatts of power. Almost the amount of power that the entire state of California consumes on peak. We only really need a software integration to enable that entire fleet of smart thermostats. They're all connected to the internet. They can all be controlled in real time to deliver grid services. So where these grids are being stressed by increasing electrification, you can't just build a new wind plant, a new solar plant, a new gas-fired power plant next month. Next year. It takes years to build these plants. In the face of increasing electricity demand, DERs are an incredibly valuable resource. And of course, the third trend that DERs provide for or help address is the increasing impacts of climate change, whether it's Winter Storm Uri in Texas or Hurricane Ida or wildfires out west. DERs offer the resilience of a network. You're not relying on a single point of failure with a large power plant. You have thousands, tens of thousands, even millions of DERs that provide incredible resilience against the effects of climate change. So the trends are really driving markets to adopt DERs more and more at scale, and DERs are continuing to prove themselves as very valuable resources for grid operators.
And you have a well-established customer base already. I mean, these are big names that you're already working with that have adopted this strategy.
That's right. We have a marquee list of name brand commercial and industrial consumers that are clamoring to do this more and more and be part of the solution.
Let's talk about a case study. Maybe to walk through what's going on in the crypto space, for example. Obviously, huge consumers of energy, and if you could use that as an example and maybe tell you how you interact with them and walk through a case.
Sure. So crypto mines are very special, very large electricity consumers. These crypto mines are now the single largest electricity consumers in the world. They dwarf what were previously the largest electricity consumers like steel plants or petrochemical plants. They also have a unique capability of being willing to instantaneously curtail power consumption because their data centers aren't considered in the traditional sense mission critical. And so as a result, Voltus has developed a way to fully automate curtailing the ASICs, the application-specific integrated circuits, power consumption instantaneously as necessary. So we have a software API directly into their mining management software, and then we can orchestrate the reduction of their power into these electricity markets that fully monetizes their flexibility. We're talking about 100, 500, even 1,000 megawatt electricity loads that can deliver almost every grid service that grids are willing to pay for, whether it's at the distribution or the wholesale market level, from instantaneous regulation response to a 1 hour capacity product for emergency purposes. These crypto mines are very special, but they want to fully automate everything from, again, the machine through the electric meter to the market to the money that ends up in their bank accounts. And we've developed a great technology to serve them.
So I think it's pretty clear there's a big total available market here to work in. You've obviously have established customer base and starting to mature as a company. Where do you see the risks for you still ahead? I mean, is it capital, people, technology, competition?
Yes. Yes. Look, there's risk, and the biggest risk is the one not taken. But what I would start is I'd start by saying the biggest strength of our software platform is the fact that it is so diverse, right? We enable every type of DER. We operate in every one of the 9 U.S. and Canadian wholesale power markets. We deliver every product within those markets, and we serve more than 40 distinct commercial and industrial markets. We have an incredibly diverse portfolio, but there's certainly risk, right? There's market risk, there's pricing risk, there's hiring risk, there's regulatory risk. These are electricity markets, and there's no way around the simple fact that these markets carry risk. We address that through scale and through diversity really well.
So we're coming up on 30 minutes. I'm going to ask my last question. I do want to get to some of the audience questions as well. Mine relates back to milestones. As investors and analysts, we all need ways to track your progress and look for things inside the company. As an outsider, let's say, what would you say for investors and people looking at the business over the next 12 months, 18 months, whatever time frame you think that are things that we would want to see or need to see to show that you're tracking on your strategy?
Yeah, I always encourage investors and our own team, for that matter, to focus on our fundamentals. We talk about 50, 40, 15, and 25. $50,000 per megawatt year of recurring revenue on our platform, 40% gross margins, 15% operating expense to acquire those megawatts, to manage them, to build our product, to manage our virtual power plants and energy markets, and at scale, 25% EBITDA margins. The business unit economics that I just laid out are really what investors should look at within the context of how big this market is. By 2030, it's estimated that there will be 2.4 million megawatts of DERs available in these markets, not counting electric vehicles, which are significant in and of themselves, significantly larger than that 2.4 million megawatts. And so it's $120 billion annual recurring revenue market opportunity. And that doesn't include electric vehicles. And so watching our unit economics within the context of how many megawatts we bring onto the platform is just a fundamental. Maintaining our margins is really a reflection of the value we deliver to customers. The 15% operating expense is a measure of how efficient we are at acquiring megawatts and managing our portfolio. And the fact that we operate with negative working capital and have very little supply chain risk makes for a very strong investment thesis. And I expect our investors and our team to hold us to those fundamentals.
Just an add-on to that is the scale as you grow, right? A lot of times you see high growth companies and there's really a lot to manage, like you said, supply chains and people and manufacturing or whatever they might be doing. But in your case, let's talk about the ability to be that high growth company and to the scale. And I think you have some advantages over other companies in that area.
Yeah, I'll just give you an example. If we can walk into, we talked about crypto mining, we can walk into a crypto mine and present our value proposition in 30 minutes. That customer can sign the agreement right then and there. And we can integrate through an API with their crypto mining management software the same day. And depending on the market, we could have that resource enrolled within 30 days and earning revenue, no cost, no risk to the customer, earning revenue, generating cash. Because we operate in a market where we're enabling existing resources, using this example, it's incredibly capital efficient. In this example, we don't even have to roll a truck. We're not actually installing anything. We're simply tunneling in through an API into their control infrastructure. It's a very unique business model. We're not, beholden to lithium ion prices. We're not beholden to some supply chain for, solar panels. We're simply picking fruit off the ground of resources that are ready for us to internet enable them, if you will.
All right, thanks for that, Greg. I'm going to take a couple questions here. The first one is, can you expand on the retail and residential market opportunity?
Yeah, we didn't really spend much time on this, but the second segment that we serve are these DER technology partners. You may have noticed recently an announcement of a partnership with Google Nest and Residio to manage a first of its kind smart thermostat program in the PJM market to deliver both capacity and ancillary services. And, I mentioned the data points earlier that smart thermostats, again, one of hundreds of use cases for DERs are tens of thousands of megawatts that really you can instantly enable through a software API. Our SPAC pro forma in 2027 shows something on the order of about 15 to 20,000 megawatts under management in our portfolio. The smart residential smart thermostat market itself could be 40,000, 50,000, 60,000 megawatts by 2030. And I suspect that's going to be maybe not a winner take all, but winner take most opportunity. That's one example. Electric vehicles are kind of the granddaddy of them all, right? There's going to be 2 million megawatts. Right. So to put that in perspective, I think I just mentioned 20, 30, 40, 50,000 megawatts of Wi-Fi thermostats. EVs are 2 million megawatts by 2030. These residential DERs at scale are really jaw-dropping.
The next question is regarding the scale of DERs. And I think what they mean by that is, do you expect more people to build bigger DERs, again, in light of the ability to maybe turn themselves into a little power plant and have a cash opportunity with you? You think that'll change the behavior as people build microgrids and DERs going forward?
Well, I don't know. By their very nature, the whole point of DERs is you have many more smaller electricity consuming, producing, and storing devices. So I think you'll see on an asset by asset level the average DER size go down quite significantly, especially if you're just looking at EVs. EVs, if they were to inject their power back onto the grid, might be 20, 50, 100 kilowatts of capability. That versus a crypto mine that might have 500,000 kilowatts of capability at a single asset. So the diversity of their portfolio is significant, but I do think on an average basis, you'll see the average size of a DER asset go down over time.
Next question is regarding renewables. Can you measure and quantify the renewables in your portfolio, which is obviously an important metric?
Yeah, so it's important to note that renewables, traditionally people think of wind and solar as being renewables, and most wind, the vast majority of wind and solar, is passive. So really what we see on our platform are the dance partner for those renewables. So you see a lot of solar coming online more and more with attached battery storage to firm up its capacity. And where solar is growing, you see a higher and higher attach rate of storage because it economically makes sense. And that storage, that DER energy storage, is what ends up on our platform.
So another question is the length of contracts. So do you have any obligations or restrictions around those contracts with your customers?
Yeah, so the basic structure of the contract is we sign a customer up to bring their DERs into the market, but we are not obligated to the customer to deliver that particular megawatt, nor is the customer actually obligated to deliver their megawatt. The value proposition and technology that we've developed creates this very symbiotic relationship where we're managing a portfolio of assets. Some of those assets leave, it could be a big box retailer shuts down a store. They could start up another store down the street or in a different county, and we'll bring that asset online. So the platform is, the value of the platform is in the diversity and scale of its portfolio and flexibility of those resources. So although we might sign long-term contracts, we're not actually obligated to deliver that particular customer's megawatt into a market, nor is that customer obligated to always deliver the value of that megawatt. It's the power of the platform and the portfolio that allows us to meet commitments while maintaining flexibility.
So I'm going to take one more question. I apologize to those we didn't get to, but we're running out of time here in the half hour. So I'll make the last question about how do you interact with customers? And I think they're referring to the DER assets themselves. I mean, because obviously they do or do not want to sell power at any given time. How does that work?
Yeah, sure. So, if Sean, I was pitching you, it's in essence selling $5 bills for $2 and really asking the question, how many do you want? You may have a DER at your facility, and it has the ability to generate economic value at no cost or risk to you. Voltus would orchestrate the control, the dispatch, the monetization of that resource, and every quarter you collect a check for allowing us to do so. There are a whole host of other social benefits for doing that, but the essence of it is an economic value proposition that in 30 minutes or less I can describe for you, and you can make a determination whether you want to take advantage of it.
And you go to that customer and ask them, do they want to provide power at any given time, right? So if you're looking, for a certain amount, and you go to your portfolio, your customer has the choice, right, to sell or not sell, or use their power, I guess, right?
That's correct. Yeah. When I walk into a big box retailer, I literally show them a spreadsheet and say, knowing our experience at other big box retailers, here's how much each of your stores could generate in net bottom line impact by allowing us at no cost or risk to you to manage these resources to deliver grid services. They've got 4 or 5 questions. If the economics make sense, we take a deeper dive. We lay out a statement of financial opportunity for them. We walk them through a demo of our technology, and we sign them up, and off we go.
And I know we've talked about it a little bit before, but you don't go to a big retailer and ask them for power in December, right? I mean, around holidays, and so that you have the algorithms also to know when they really need this, and you ask them if they can provide the power at that given time, right? They have choice at any minute to say yes or no.
Yeah. So, our software platform, again, manages 2 sides of the market. So on the grid side, in the winter, as opposed to the summer, these resources are needed less, right? There's less electricity consumption because generally speaking, electricity trends with hot weather. So in the winter, the resources are needed less, and each customer on the other side of the equation has both operating and economic constraints. Those attributes of economic and operating constraints are baked into the software. And on the other side, the market has requirements of our portfolio. The software synthesizes all of that so that we can deliver our obligations to the market while making sure that we don't violate any of the operational or economic constraints that each DER asset might have.
Okay. Understood. Thanks for that, Greg. I'm going to turn it back to you for any final remarks, and we'll end the day today.
Thanks, Sean. So, our final remarks are pretty simple. We encourage everybody to learn more about this massive transition of our global $3 trillion per year electricity spend away from the central power station and dumb electricity loads, if you will, to a digitized, a distributed and decarbonized grid that delivers less expensive, more reliable and cleaner power to consumers.
We appreciate it. Thanks for your time again, Greg, and for all the participants today. We look forward to having you back and looking at some exciting times. So thanks again, Greg.
Thanks, Sean. Take care.